All right, this is a video on 7.4. I'm just going to call it logarithms or logs. I'm going to introduce you to this idea of what is a logarithm. So if I'm trying to figure out what x is here, what is this? 3 times x equals 24. How do I undo this multiplication? I show that I'm dividing with this division bar. I'm going to divide both sides by 3. So division undoes multiplication. What if I have x cubed equals 27? How do I undo that? I take the cubed root of both sides. I have this symbol, a root. What if I have 3 to the x equals 243? How do I undo this x in the exponent? Well, I can log both sides. So it's sort of my symbol for undoing an exponent. I'm not going to show you right now how that then works out, but basically a log undoes an exponent just like a root undoes a power and division undoes multiplication. So that's the first thing you can think of. It's sort of a symbol, except we use a word. The next most important thing to know, understand, be able to do, and or memorize is the definition of log. So it's really being able to translate this statement. Log, and say it, log base b of y is x. Looks kind of complicated and unfamiliar, but really it's quite simple. All this means is b to the x equals y. So this translates to b to the x equals y. So it's quite simple. If you can translate this into this, exponents and logs will should be quite comfortable for you. So log base b of y is x literally translates to b to the x equals y. So if I look at this statement, what does this really mean? 2 to the 5th equals 32. I'm translating that. And your book will ask you to go back and forth. Translate this into a log, translate a log statement into an exponential statement. So that's good because it forces you to learn the definition. Here's some examples. Sometimes they say evaluate this log. Well, here's something I like to do. I like to put an equals x over here because then I can just translate this. 2 to the x equals 8. And we all know what that is. X is 3. So this statement translates to log base 2 of 8 is 3. Again here, 12 to the what equals 12. That's what the log questions is asking us. Just like back with a cubed root, if you read this, it's what times itself 3 times. What times itself 3 times. Here, I'm asking, this is saying 12 to the what equals 12. So 12 to the x equals 12. You might not have to write that out. We know x is 1. So this evaluates to 1. 12 to the 1 equals 12. 4 to the what equals 1. Hopefully we all remember now that x is 0. So this sentence is log base 4 of 1 is 0. Getting a little tricky here. 1/5 to the what equals 5. Well, I need to flip 1/5. How do I flip 1/5? I raise it to the negative 1. So log 1/5 of 5 is negative 1. More. Again, reminding you of some other exponential relationships. 3 to the what is 1/9. Not only do I need to flip it, I need to square it, so that must be a negative 2. Therefore, log base 3 of 1/9 is negative 2. This is saying 36 to the what is 6. Well, how do I get 6 from 36? I have to take the square root, right? I'm not dividing it by 2. I have to take the square root. What exponent indicates a square root? That would have to be a 1/2. So log base 36 of 6 is 1/2. And then in terms of evaluating, sometimes you can use your brain, sometimes you need to use a calculator. Now your calculator can work in two bases, and we'll talk more about this later. It can work in base 10 or it can work in base E. So when we just write a plain old log without a base, it's assumed that that's a base 10. So if you want to go ahead and put the 10 in there, you can. I don't know what that is. 10 to the what is 100? We know that. Log of 100, therefore, is 2. 10 to the 2 is 100. ln is basically a base E, the logarithmic natural, the natural log. So this is asking E to the what is 71. Well, I don't know what that is. Remember, this is 2.718. So if you go to your calculator, you'll notice the ln button, the logarithmic natural button, is just below the e to the x button, and they're inverse functions. So if I just type in the natural log of, what did I have, 71, I get 4.26. So this is 4.26. Here I could use my brain. Here I'm going to need to use my calculator. What about this one? Log again, base 10. I don't see anything. So this is saying 10 to the what is 50? Well, who knows? 10 to the first is 10. 10 squared is 100. So it's got to be somewhere between 1 and 2. So again, this is a calculator one. I go to log of 50. And it tells me 1.7, essentially. That's what I expect. I guess it's approximately 1.7. This would be an approximately 2. So there's a little bit about the definition of logs, how to evaluate logs, how to translate logs. Next up will be graphing and a little more on inverse.